Hey guys, I'm Sunny, and today I'll be teaching you guys my way of understanding the basic differentiation rules. In this video, out of the chain rule, product rule, quotient rule, exponential, natural log, trig, related rates of change, limits, and parametric functions, we'll cover the first 5. Before we start, it's important to understand that the derivative of a function dy over dx is actually d over dx times y, the derivative of y respect to x, and the second derivative of a function d squared y over dx squared is actually d over dx times the first derivative of a function dy over dx. First of all, the most important rule out of all, the chain rule used for deriving composite functions. As written in the formula sheet, the derivative of the composite function fg composed of function f and function g is equal to the derivative of the outer function f times the derivative of the inner function g, which is also written as dy over dx is equal to dy over du times du over dx, as the du's cancel each other. Let's look at an example to help understand this better. For this composite function, x squared plus 2 inside the bracket is the inner function and y as a whole is the outer function. And if we said the inner function x squared plus 2 was u, the outer function y can be written as u cubed. From this, now we can work out the derivative of the inner function u in terms of x and the derivative of the outer function y in terms of u. Now using the chain rule, we can work out the derivative of the function by timesing the derivative of the outer function by the derivative of the inner function. And always to remember to substitute in the actual values of u to get the final answer. Secondly, the exponential rule. According to the formula sheet, it is said that the derivative of the function y equals e to the power of x is equal to itself e to the power of x. However, we always have to consider if the function is a composite function or not. For example, for this exponential function composed of two different functions, the power 2x minus 1 is the inner function. So if we set the inner function 2x minus 1 was u, the outer function y can be written as e to the power of u. Like before, now we can work out the derivative of the inner function u in terms of x and the derivative of the outer function y in terms of u. So we can now use the chain rule to work out the derivative of the whole function. And always remember to substitute in the real values of u to get the final answer. Thirdly, the natural log. According to the formula sheet, it is said that the derivative of the natural log ln x is equal to 1 over x. This is because as ln x is equal to log base ex, which can be written in index form as x equal to e to the power of y. Using the exponential rule from before, the derivative of this dx over dy is equal to itself. Therefore, dy over dx being 1 over e to the power of y. And because e to the power of y is equal to x, dy over dx being equal to 1 over x. However, we always have to take composite functions into consideration. This example, ln 3x squared, the 3x squared inside the absolute value is the inner function. So if we set the inner function 3x squared was u, the outer function y can be written as ln u. Now being able to derive the inner function u in terms of x and the outer function y in terms of u, we can use the chain rule to figure out the derivative of the whole function. Once again, don't forget to substitute in the actual values into u to get the final answer. And hence this is why the natural log rule is also written like this. And of course, always simplify your answer fully. Fourthly, the product rule. According to the formula sheet, it is said that the derivative of the function f times the function g is equal to the function f times the derivative of the function g plus function g times the derivative of the function f. So for this example where x cubed is the function f and x plus 3 is the function g, the derivative of the whole function is equal to f times g dash plus g times f dash. And always remember to simplify your answer if you can. Lastly, the quotient rule. The formula sheet states that the derivative of the function f divided by function g is equal to the function g times the derivative of the function f minus function f times the derivative of the function g divided by function g squared. So for this example, where x is the function f and x plus 2 is the function g, the derivative of the whole function is equal to g times f dash minus f times g dash over g squared. However, you always want to avoid using the quotient rule as it's the most complicated and it's easy to make mistakes. So for example, even though this looks like a division of two functions, you need to change its form to use the product rule instead. And remember, because the function g is a composite function, you need to use the chain rule to get g dash. Thanks for watching, and remember, this is my way of understanding these rules, so it may not be yours. If you have any questions or topics you'd like us to go over, pop it down in the comments below and subscribe for more.